off the chain.
Welcome everyone to another episode of Off the Chain with your host Armel. And today we have Phillip Kruger from Red Hat. And Phillip, how are you?
I'm good, thanks. I'm good, thanks. And you?
I'm brilliant. Thanks for joining us on the show, Phillip. Would you like to give a brief introduction about yourself?
Yeah, sure. I'm Phillip Kruger. Like you said, I work for Red Hat, and I mostly work on Microprofile and SmallRye. I specifically look after, at this point, Microprofile GraphQL and the SmallRye implementation of it, and Microprofile OpenAPI and the SmallRye implementation of that, and then also the integration of that into Quarkus.
Oh, great. So today I want to talk about your work on the Eclipse Microprofile and GraphQL.
Okay.
I'm a big fan of Microprofile. And I was actually saying that you also work on Quarkus, right, which I'm a huge fan. And now, for our listeners, could you tell us what the Eclipse Microprofile project is?
Okay, so this is my definition, so not an official definition, but it's a set of APIs or specifications that enables a developer to create microservices or cloud-friendly applications. So it's really just specifications and APIs, and then you can port. It creates a portability so that all the different implementations, if I create a microprofile application, I can port between these implementations. So as an example, OpenLiberty has an implementation, but Payara also has an implementation. And similarly to Jakarta or Java EE, I can code against the API and move implementations.
Okay. You mentioned Jakarta EE there.
Yep.
Right. So how did the Microprofile project come about? Because you could use Jakarta EE, previously known as Java EE 8, I believe.
Yep.
Right. So how did Microprofile project come about?
So it's again, I'm not the expert at this, but kind of my understanding is that at a specific point in Java EE's history, things started going very slow. So the specifications kind of took a long time to kind of get updated or new specifications being added. And in the meantime, the landscape has changed. Suddenly microservices became popular, the cloud became popular, and the implementation, the people implementing Java EE kind of got together and said, let's create a separate set of standards to specifically kind of fill this gap and move quicker and be able to do breaking changes. And that's kind of how it started. I think it's about 4, maybe 5 years ago that it started.
Mm-hmm. Okay, so Java EE being really big standard, it covers everything from server side to front end development. So for the different JSPs and JSF, server side, microservices, batch, application. So what is the focus of Microprofile? Is the Microprofile also looking at the full, technologies landscape like Java EE, or is just specializing on a specific thing?
Yeah, I think it's specifically just targeting the gaps that exist because of cloud, like I said, and microservices. It builds on top of some of the APIs of Jakarta EE, so JAX-RS for REST services, JSON-P, JSON-B, and CDI, for context and dependency injection. But then it adds a bunch of APIs to work in distributed applications like fault tolerance and metrics and health and things like that. If I can share my screen, there's actually a good overview picture.
Oh, yes, go ahead.
Let me see if I do this, share screen. So this presentation you can actually just download from microprofile.io. If you need to give a presentation, there's some nice information on there. But this is the APIs currently in Eclipse Microprofile 3.3. So you can see, like I've mentioned, fault tolerance, metrics, JWT propagation, health, config, another REST client, even though JAX-RS has a REST client. This is a type-safe REST client, Open API and open tracing. And then there's a few that's not yet part of the platform, and that's where GraphQL fits in.
Okay.
So the process of Microprofile is that if you want to add a new API to the umbrella, you start off by proposing it and playing in a sandbox and doing a POC. And then if the community thinks it should go ahead, then you become the standalone API, which means you also release under Eclipse Microprofile, but not as part of the platform.
Okay.
And then maybe later, if you get to a point where you're mature enough, you could be included into the platform as an API.
Mm-hmm. That's very interesting. And actually, one of the things I was going to ask you is what makes Microprofile cloud friendly? And it's good that you have this diagram here on the screen.
Yep.
Right. So maybe you could take us through some of the stuff that makes Microprofile more cloud friendly.
Okay, so if we can actually just start with health. So if you think of health, if you deploy today into a cloud environment like Kubernetes or OpenShift, the Kubernetes manage your application for you, and to be able to manage your application, it needs to understand whether your application is healthy, because if it's not healthy, it needs to be bounced or restarted.
Okay.
So you need an API to be able to create these health endpoints, and that's what the health API gives you. So you can very easily add a health endpoint, and automatically it will be exposed in Kubernetes so that it can be managed. Similarly, previously when we created monolithic applications, we can very easily monitor that application because it's one application to monitor. Where if you move to a microservices or distributed architecture, you suddenly have hundreds of small little applications that has some relationship with each other.
Mm-hmm.
And so metrics allows you to actually export metrics from your application and the base that it runs on into some shared central place so that you can monitor your application.
Okay,
fault tolerance. Yeah.
Sorry. So will the metrics be something similar to the log activities?
Yeah. So it's maybe a bit more structured, because a log is actually just a log, and then there's tools that can make sense of the log, where metrics is an actual output of your application, and you can actually have specific business logic application output into your metrics. So if I have a bank application that credits or debits because people are doing transactions, I can have metrics that says how many times do we actually do a credit or a debit, or what's the sum total, or you can do more business specific things. Fault tolerance is important again because of distributed systems, because previously when I worked in a monolithic application and one part of the application calls another part, I'm fairly sure that part is up and running because I'm up and running and we're part of the same application. Where now I might be calling something which is running in a separate application, and I need to be able to have strategies around what happens if that application is down or slow or something like that. So this gives you a nice programmatical development model to handle fault tolerance. So you can do a retry, or you can do a fallback. So if that's not up, what is the other option then? And things like that. So again, cloud friendly type, microservices friendly type stuff. Config is added. I think it's something that we've done all along even in monolithic applications, but it's never been properly standardized. So I know that me personally, I've used just plain old resource injection to inject a properties file in Java EE to be able to do configuration, where this API is much more defined in terms of how to do config and the ability to actually have levels. So I can overwrite a config with another config source. So I can have multiple config sources, which allows me to very easily change config between environments. REST client is like I said earlier, it's even though there is a REST client in JAX-RS, the REST client in JAX-RS is this kind of builder pattern dynamic type client where the REST client defined in Eclipse Microprofile is a type safe client. So I work with objects and it binds back to the object automatically. So it's very handy. And I'll actually touch on that a little bit later if I talk about the GraphQL client that we're working on at the moment. OpenAPI is everybody that's used JAX-RS, I'm pretty sure has stumbled across Swagger, and Swagger has now been standardized under, I think, the Linux Foundation, if I'm correct, and is now OpenAPI as a standard. And then this OpenAPI brings that standard to Java, basically. So it gives you a standard way to actually do what we've previously used Swagger for. And this will then generate the OpenAPI schema document for your JAX-RS service. And then open tracing is ability to trace an application through multiple services. Again, because we're not a monolithic application anymore, we're now a distributed applications. We want to be able to trace that, trace something through all those services and back so that we can see what's happening. So that's kind of plus minus that. I'm not too familiar with this apart from GraphQL, the standalone applications, but I can obviously talk about GraphQL.
Okay. Thanks. I think that's a very good description of what makes our microprofile cloud friendly. And you mentioned things like fault tolerance, which I understand perfectly. The ability to handle faults if anything happens. Our metrics, get some of the right information in front of the. It could be used by system. It could be used by a human. So I guess the metrics will be human readable, business focused as well, as mentioned. How many times this endpoint has been called, right? So you can run all those. So
I actually missed JWT propagation. I jumped over that. So we can quickly talk about that, because I think one of the difficult things to do in a distributed system is security. Where previously, again, if I had a monolithic application, I secure something, and then I have a user that has a session, and I can check whether or not the user has the ability to do what he's asking to do. Where with a distributed system, I have to propagate that with my call, and that's exactly what this does. Is it allows you to use JWT tokens to propagate the actual security state between multiple services. I think that's everything there. Yeah.
Security is always important anyway. Cloud native or monolithic, but as I mentioned, in a distributed architecture, that are harder to do session management. All right.
Yeah.
Which is something what you touched on briefly there. So there's a REST client in Microprofile, Eclipse Microprofile, but GraphQL has been making a lot of advancement as well, so getting more popular, GraphQL. So what exactly is GraphQL?
So I'm going to switch. Can you still see my screen if I switch tabs?
Yes, I can.
Yeah, so I'm going to actually just show you this, GraphQL.org. They have a nice explanation of, in general, what is GraphQL. It's really just a query language for your API, which in my personal story is that I worked at a company where we had to do a lot of integrations with other departments inside the company, and we created REST endpoints for them. But we ended up kind of having to add new endpoints for every consumer, because all the consumers had a specific need. So we had a website that wanted a lot of the data, but then the mobile team only wanted some of the data, so they didn't want to stream all the data over the network. And then we had a third party that wants also some of the data, but more than the mobile, but less than the web. So we ended up adding all these endpoints specifically to the consumer, which is obviously not a very scalable solution if you have to add an endpoint for every consumer. So at that point, that's how I got to GraphQL, because I wanted to be able to let my consumers query exactly what they want, so that they can ask, this is what I'm interested in. So GraphQL solves the problem of overfetching and underfetching. So overfetching means that I'm a mobile client, I want to display your name and your status on my mobile app, but your endpoint returns a huge JSON file with all your details that I have to potentially stream over a 3G or 2G network, depending on where you're at. So that's fetching too much data. And then the other option is when the endpoint doesn't get all the data that I need, so I need to make subsequent calls to go and fetch the data so that I can build the information that I want. And then the worst is a combination of the two, where I don't have the one endpoint that I call doesn't provide me with all the data, but the subsequent calls provide me with too much data. So I have both options, both issues. So GraphQL allows you to actually call your endpoint, but ask specifically what is it that you're interested in.
Okay.
And that's kind of my story, how I got to it. And then.
Okay. So you mentioned that with GraphQL, underfetching and overfetching can be solved using GraphQL.
Yeah.
You also mentioned that if the endpoint has to make another call to a different endpoint, you can add that to GraphQL. So is that implementing orchestration?
It's not really orchestration. There is some tools that does GraphQL orchestration. That's, I think, still fairly new. Apollo server is busy doing stuff with that. So it's not orchestration over multiple services, but it's orchestration within your service. So the example that I'm going to show, if we have time, is a person or people data. So all the data around some member of whatever, the bank or the user, and then the status, which is two separate systems, but you want to kind of combine them into one. So in your application, you can combine them into one with both REST and GraphQL. But because GraphQL is queryable, I might not ask for the status. And then I don't want to make the call to the status system to actually aggregate that data into the result. Where with REST, because you always return everything, you're always going to make the call to both backends to get the data, to aggregate them, to return it, even though the client might not care for it. So what you can do with GraphQL is kind of merge those two together. And I can actually show that in a small demo as well.
Okay, I mean that would be good to see a demo how to you actually using GraphQL, and so just so that I can understand. I love this. My favorite IDE, NetBeans.
Oh, so you can see my screen.
Yes, I can. I can see your screen.
Okay, I wasn't sure if.
I can see it. You have your IDE up and running. So what I wanted to ask you about GraphQL is that so you could make a call to another endpoint within the same service. Is that what it is? But not a separate service.
Yeah, so with GraphQL, you actually only have one endpoint. There's no multiple endpoints, which is kind of part of some of the problems with GraphQL, is that there's only one endpoint. So if you come to security as an example, previously with REST, you can secure the endpoint and then control access based on the endpoints, where with GraphQL, there's only one endpoint. So you need to secure the questions being asked. But yeah, so there's only one endpoint, and the work, like I've mentioned, with some of these tools like Apollo Server, or there's a few others, is trying to allow you to aggregate this into aggregate multiple into one. So merging multiple GraphQL endpoints into one GraphQL endpoint on a type of a API gateway level. And this is not what Microprofile GraphQL does. Microprofile GraphQL allows you to create GraphQL endpoints very similar to the way that you would create REST endpoints with JAX-RS. So it's the same programming model, and I'm going to show that now. But we haven't gone up to the level of trying to merge multiple endpoints into one. It just takes your endpoint that you currently have and give you the ability to be cleverer around how it can be queried.
Okay, and this, if someone was trying to be really use the worst approach to development, where you should not be doing things. If someone wants to make some REST and GraphQL, right? I want to wrap my REST endpoints around GraphQL. It sounds like something that shouldn't be done, right?
Yeah,
but
it can be done. I would potentially advise to rather wrap the underlying business logic layer, because typically your REST layer sits on top of something that performs the actual business logic. and I would just wrap that same business logic. And let me actually jump into the example, then I can show you. So can you again see my browser?
Yes, I can.
Okay, so this is the example. It's available on GitHub, so you can just go grab it. It should work out of the box. There's a blog post around it. There's some presentations I gave, and then it actually shows you how to run the example with some example GraphQL calls, so which we're going to do now. And I'll show you the Quarkus one, but this also runs in Wildfly. Quarkus is actually now, it's part of Quarkus 1.5, which has just been released. So you don't have to do anything. You can just download 1.5 and you have it. Wildfly, we added manually because it's not yet part of Wildfly. And then if I show you the code, so back into my IDE, so I'll start off with the REST API. So here's a typical REST API, which if you've been using JAX-RS or even Spring Web, this is a very familiar way of coding. So everything is annotation based. So I have a REST endpoint under /person, and this tag is actually open API so that I can create better documentation. And then I just get a person based on an ID, or I get all the people in the database. This database I share. So this is the backend part I'm talking about that I'm now sharing between the two examples. So if you compare that with what we've done with Microprofile GraphQL, it's again very similar. This is actually profile, so I must compare these two. So this is a profile server, which combines two things. So it combines a person and the actual profile that we've created for that person, or the score that we gave that person. So this is the JAX-RS example, and if you look at the GraphQL one, it's very similar. It's annotation based. The code is the same. The only difference is that I don't have an add get, I have an add query, and I might give it a name like profile foo. I don't have to give it a name. If I don't give it a name, it'll just use the method name without get or set. So from a developer point of view, it's very familiar. It's what you're used to, but you just add an add query, and this will now make this endpoint queryable, which means I can actually ask specific parts of what is it in profile that I want. Now, if you go to profile, this is a normal Pojo bean that contains really just a person and a person score. And a person is another bean that contains quite a lot of fields, as you can see. And this is the problem we're trying to solve, because if I only ask for the title and the name, I don't want to actually stream all of this down the bad network connection. So I've already compiled this into native mode, so I'm just going to run it in Quarkus. So it's started up. It's now started up with both JAX-RS and GraphQL. So if I go to Swagger UI, I can see the open API endpoints that's been created. So if I take an example of getting a profile for a person, this is a normal get that I do. So this is normal JAX-RS, this is what we used to, but I get everything back. So this is quite a lot of information. Now, if I only care about the person's name, surname, and the scores that it gets, I now need to go pick this out of this payload and display it onto my screen. But the network traffic has already happened. The other option that you have with REST is something called Hatios, where I can break it up into pieces. So I can say, get me person one, and the response then contains information on where to find different parts. So I need to make a subsequent call to there to get the person, and then a subsequent call to there to get the scores, and then I can kind of combine them myself. This is not really solving our problem because, again, we want to be fully queryable depending on the client. So that code that I showed you, this is the actual execution part of it. And then in Quarkus, you can now go to GraphQL UI, which is very similar to Swagger UI, except it's for GraphQL. And here you can see I'm doing a query now, so I can actually now say, let's actually do profile so that we can compare the two. So first of all, I actually have code insight in this little web IDE of me, and that's because GraphQL comes with a schema defined as part of the actual endpoint. So you can see here to the right is the Document Explorer, which will show me all the queries that I can do, and it will show me what is a person and what is an address, and I can actually traverse the actual schema of this endpoint. But if, as an example, I can now ask for a profile for person 1, and now I have the ability to say exactly what is it that I want. So I want only name, and let's say surname, and then I want scores, name, and value. So the payload that I get back is obviously much more specific to my needs. And if I'm a mobile and I don't want the scores, then I don't ask for the scores, and I get much less data back. So this it solves the overfetching and underfetching problem, but it also allows consumers to evolve at a different pace than the server. Where previously, if a consumer is asked, needs something specific, they have to go to the backend team and ask for that endpoint and inclusion and wait for it to be built and wait for it to be deployed, and then they can do it. Where now, I can just ask specific questions, and I can evolve at my own pace, which is one of the reasons why Facebook initially started GraphQL is specifically for that, because they have multiple front-end consumers, and they want them to be able to work without having to chat to the backend guys. So what I've done here is, if I go back to my code,
can you show what it look like using the normal REST for the Swagger UI? Because you have both of them running, right? You have the GraphQL running and you have the REST running.
Yeah, so this is the REST one running.
Yes.
What is it that you want to see?
I wanted if you could show the overfetching using REST.
Yeah,
yes, we can see that in the response body there.
Yeah, so there's the overfetching, right? So I fetched all the data because we don't know what it is that you want, so we just give you everything. And this is maybe fine if it's a server to server, or if you know that you have I must say, even server to server, it does add to the network traffic. So the busier you get, the more stuff you send over the network that's just being ignored on the other side, which is what we're trying to solve here. I guess the bigger problem is when you do something like this, where we say, get me all the persons. Now, in this case, I only have 10 people, so it's not that much, but it's still a lot of people. Where with GraphQL, if you start returning a collection, so let's do people. Now I can still say, just give me the names, and even though it's a lot of people, this would have been 70 fields per person. It's now only 1 field per person. So it definitely allows you to optimize your response. One of the other things that I wanted to show is, if I go back here, this is the REST endpoint, and as you can see, what we do to create a profile is we go get the person from the person backend, and then we go get the scores from the scores backend, and then we create the profile. In GraphQL, I might have never included scores as part of my query, which means I don't want to make this call. Because this might be an expensive call, or it could be a slow backend, or in our example, this was actually making a call to an old AS400 system, as an example, and it was very slow. Now, we don't want to penalize somebody to go and do this call if they didn't even ask for the scores. So what you can do in GraphQL is, if you go to this example, I now just query a person which doesn't know about scores. But then I can hook up the scores to that person by this annotation. So I say, if the response type is a person and there's somebody wants the scores, call this method. So if we go to, can you see this? The log file?
Just a second.
Okay. So I'm going to make this initial call again. So do person. And person ID, let's do 2, and then I'll ask for names and surname and score and name. So now it's gonna go to both. Let's do name and value, right? So now it should go to to both the person and the score system. And you can see there I'm getting, this is the log file, this is in the actual backend, getting person 2 and getting the scores for that person. Now this is what I don't want to do if the person didn't ask for scores. So if scores wasn't part of the query, I now only make a call to person, which is kind of what we're trying to solve with that annotation. One of the other things that's quite nice about GraphQL is the ability to do partial responses based on exceptions. So I'm simulating an exception here by basically adding another field called scores2, but just throw an exception. So pretend that the scores database is maybe down. So we don't want to penalize the information that we have, not return those, which in rest would have been the case. We would have just thrown an exception and you'll just get one big exception. But here, if I do scores, normal scores, that's the one that's working. And now maybe suddenly the application goes down. So now we can still respond with what we know, which is the person information. And then we say that scores, we have a null, and here's your exception, which is quite cool. So depending on what the client is, they might still show part of the screen.
That's really cool. Yeah, that's really cool.
The other thing that you can do is, I hope I get this right, I might have to copy it from my example, but I can do something like, I want person 1. Let's just do that again, and then we also want person 2. Maybe that's my friend or something, depending on the screen that I built. So that's person 2. Let's just change that to 1. And I don't care about the scores for person 2, but I just want the name and surname. And then I can combine these two queries into one, and I get both back. So I have person 1 and person 2. So again, it's one network call, but I'm getting back exactly what I'm asking for, which is also quite nice. And I get all of this for free by basically just doing add query onto my method that's existing already. This is the existing method that you're already doing with JAX-RS. So that's kind of the server side, and everything that I've shown you now is, like I said, it's already in version 1 of the specification. It's been released. It's part of Small Rye, and it's now part of Quarkus, and I think it's part of Open Liberty. If it's not in the current release, it will be in the next release of Open Liberty, and I'm sure it will soon be in some of the other runtimes as well. What we're working on for, I don't know how much time we have left, so you must stop me because I can go on forever.
No. Feel free. I mean, this is exactly what the subscribers and listeners always been asking. So you're really going to GraphQL, showing how it works. What I like there is the partial fetching, right, and the nesting. So the nesting of the calls, that's very cool. So that you don't have to make multiple calls. It's just one call, go over the wire, and come back with all the result that you need instead of making multiple calls. I think that's really cool.
So what we're working on at the moment for the next version, and parts of it is already in Small Rye, and it's kind of usable if you include it yourself. So this is a client example. So very similar, like I've mentioned, to JAX-RS client or Microprofile REST client. Both of those programming models will be included in GraphQL. The one that I'm going to show you now is one that's very similar to Microprofile REST client, where on a very high level, you want to define what is a person for you as a consumer of the service. So in my case, I can now say, well, for me, a person contains the ID, the title, the names, the surname, and the scores. And I don't care about the other fields. So I create my POJO that makes sense for me. Same with scores. So I don't have all the fields that the server-side score is on, only the ones that I'm interested in. And then I can create this interface very similar to Microprofile REST client, where I don't have to provide the actual implementation. I just mark it as a GraphQL client, and I basically say what is the operation I want to do, and then in my main method I can I should be able to inject it. That isn't working. I must still figure out why that's not working, but then I basically just inject that and use the person client, and this will actually make the call and populate the person for me over the wire, all the fields that I want. So I actually haven't run this recently, but let's see. I should be able to do, let me do it on command line. Yeah, so I want to go to the Quarkus client. I'm using Quarkus command line interface. I'm not sure if you know that, but it allows me to kind of just run something and then it shuts down. So
Okay.
let me just see what's in target.
I haven't used that one yet. I haven't used the Quarkus command line interface yet.
So I'll do Java -jar, Quarkus, snapshot, runner. So this is basically doing exactly that. I'm just printing it out to console. So now I've made that call and I print it out and I'm getting the information back that's in my Pojo, which is quite cool. The other client, which I don't have a demo of, is more similar to the client that's included in JAX-RS, which is a builder type pattern where I can say I want to add a query, I want this fields. It's more dynamic. I don't have to know the fields at build time. I can maybe discover it at runtime. But we're still working on that and a whole bunch of other things for GraphQL. So I'm going to stop talking now and give you a chance to ask maybe questions or what else do you want to see?
No, that's very interesting, and thank you for the demo. I think that's brilliant. It shows exactly how easy it is to implement GraphQL using a microprofile. All you did was just add extra annotation to some of the methods, and just like that, it gets exposed as a GraphQL endpoint. Really, really good. So some of the stuff that I picked up from there is that for GraphQL, you only need one endpoint for GraphQL, while with REST, you could have multiple endpoints. Right.
Yeah.
So two things being solved by GraphQL, from what I understand, is overfetching and underfetching.
Yeah.
Right. So if you're to write a microservice that had a database of 10 tables, right, but you don't want all the information from the tables to be fetched at once, and you don't want to have too many endpoints for each one of the tables, then you use something like GraphQL, really. Right.
Yeah, and one of the things that we're working on at the moment for version 1.1 is something called a context or info or something like that, which will allow you to inject the context of the current request. So if you use JPA as an example, or you use JDBC, or you use NoSQL, that context will give you information on the question that's been asked, and you can actually optimize the backend query as well. Because at the moment we've optimized the network part, but to get the person, I still did in my case it's all memory, but in a JPA example, you would still get all the data from the database and then only filter it on the boundary before you go over the network, where this will allow you to actually also optimize the query to the actual backend, whether it's NoSQL or JPA or whatever. So that should be in the next version as well. So that will allow you to even optimize closer to your data source.
I think I lost the sound there for 1 second.
Oh, sorry.
No, that's fine. Your last word was optimize the data source.
Yeah.
All right. Okay. So you touched on that earlier, but what does GraphQL mean now for microservices architecture? All right.
Well, one of the things that we want to get right is from a development point of view, it needs to be familiar to developers, and I've shown now that if you know JAX-RS, it's gonna be very easy to get to know Microprofile GraphQL. So the development model is the same, but it does allow you to create APIs that's queryable, which means you might have less actual endpoints because you have one endpoint that's queryable, so your consumers can all use the same endpoint, which means the network traffic between your microservices should be less, and that's all good.
So can you still implement the health and metrics on the GraphQL endpoints?
Yes, so that's actually a good question, but it's again one of the things that from a spec point of view we're busy specifying how that will work. In SmallRye, we've implemented both open tracing and metric support. So I don't think it's in the version that's in Quarkus at the moment, but it should be in the next version then. you will automatically get metrics for your endpoint out of the box based on microprofile metrics, and the same with tracing. And we're actually adding support in SmallRye for bean validation at the moment. But all of those things will eventually move up to the spec, and it will be specified. We're just doing it implementation first because that's kind of the way in which microprofile works.
I mean, it's really great, and thanks, Philip, for showing us the demo. Thanks. Actually, this is almost a crash course into GraphQL, right?
Yes.
It was very detailed. I think it was very detailed. It has lots of information that we can consume easily, right? And personally, I come across GraphQL a few times. Didn't implement it before, but seeing your demo and how easy it was to implement using a microprofile, I think I will be trying it very soon. All right.
Yeah, please. And I'm available online. People are welcome to ping me if they have questions or talk on the group. We have a microprofile Gitter group, so ask questions there or on the mailing list. We would love to get feedback.
Definitely. So before we, thanks again for coming on the show. And before we go, do you want, any parting words?
Yeah, I think that was it. So please reach out if you have any more questions. We would love to get feedback.
Okay. Thanks, Philip. So this was Philip on our Hostation podcast, and Philip is a contributor on GraphQL for Microprofile, also working on the Quarkus and SmallRye. All right. So thanks, Philip, and thank everyone for listening. This is your host, Armel, and I will see you next time for another demo. Great. Thanks, everybody.
Cheers.